Most security incidents do not start with movie-style zero-day exploits. They begin with very normal bugs in very normal code, written by busy people trying to ship features. An unchecked input here, a quick string concatenation there, a copied snippet nobody fully understands anymore. Over time, those small decisions turn into the exact weaknesses attackers quietly depend on.
This audio is developed by Bare Metal Cyber as part of the Tuesday Insights feature from Bare Metal Cyber magazine. The focus today is secure coding foundations, not as a slogan, but as a set of habits that make those everyday bugs much harder to introduce. As you listen, think about the code you touch, review, or rely on, and how a few simple foundations can change the story when something goes wrong.
Secure coding foundations is best understood as a way of writing and changing code, not as a particular product or checklist. It lives in the patterns developers reach for when they accept input, talk to a database, render a page, or log an error. You can think of it as a collection of guardrails, shared helper functions, standard patterns, and small rules that keep familiar bug classes from ever making it into the codebase. Tools and frameworks are important, but they reinforce these foundations rather than replace them. You can also place secure coding in the larger development lifecycle. It shows up when requirements are written, when designs are sketched out, when code is implemented, and when peers review each other's changes. If those steps assume security from the start, then static analysis, dynamic testing, and penetration tests become safety nets. If they do not, the same categories of bugs appear again and again, and every assessment feels like déjà vu. Secure coding is the glue that connects development work to security outcomes in a predictable way. It helps to distinguish secure coding foundations from nearby concepts. A secure software development lifecycle covers many layers: architecture choices, threat modeling, change management, release controls, and more. Secure coding is one slice of that picture, focused on how individual units of code are written and reviewed. It is also different from memorizing a list of famous vulnerabilities. Knowing the names of bug classes matters less than having muscle memory that avoids them, regardless of language or framework.
Attackers care about the details of how you handle each request or job your system processes. A user types into a form, an application programming interface receives a JSON body, or a background worker pulls a message from a queue. At each point, there are assumptions about what input is allowed, how it will be cleaned up, and what happens when it is not. Secure coding begins with making those assumptions explicit and consistent instead of leaving them to chance. When the rules are clear and shared, entire categories of bugs quietly disappear. The basic building blocks are familiar. They include input validation, output encoding, safe database access, solid authentication and authorization checks, careful error handling, and meaningful logging. None of this sounds glamorous, yet attackers live in the gaps between these pieces. A field that validates some inputs but not others, a template that escapes output in most places but misses one edge case, a query that uses parameter binding except for one quick fix. These are the cracks where exploitation becomes possible. Secure coding is about tightening those seams with standard approaches instead of improvisation.
Picture a simple example: a user updating their profile in a web application. The browser sends a request with new values. The application checks each field for type and length, normalizes formats, and uses parameterized queries for every database change. If something looks wrong, the user sees a generic error, while the server logs contain enough detail for a developer or incident responder to understand what happened. Downstream, any job that sends confirmation messages pulls only sanitized data. In that one flow, you can hear the main pieces of secure coding at work: strict input handling, safe data access, controlled error responses, and clear logs. Those foundations depend on a few big assumptions behind the scenes. One assumption is that teams share common libraries and patterns, rather than inventing their own solution for each feature. Another is that code review is not just about style or performance, but also about spotting recurring bug patterns. A third is that tests include edge cases and unexpected input, not just happy paths. When these assumptions hold, tools like static analyzers and scanners amplify good habits. When they do not, tools just keep reporting the same kinds of issues because the underlying patterns stayed the same. You see secure coding foundations most clearly in everyday features: logins, search boxes, file uploads, dashboards, and administrative panels. Attackers probe those places first because they are both exposed and often rushed. A strong foundation means login code that resists brute force, avoids leaking whether an account exists, and uses sessions that are hard to steal and easy to invalidate. It means search inputs that are validated and then used safely, without string concatenation into queries or templates. It means file uploads that never treat user-supplied data as executable content. For many teams, a good starting point is a focused, quick win on one high-value path. That might be the main search endpoint, a self-service password reset flow, or a public application programming interface used by partners. The work is concrete. Document all the inputs, add strict validation, enforce parameterized access to the data store, and standardize how errors and logs look. This can often fit into normal sprints and gives immediate risk reduction in places attackers are already interested in. It also becomes a pattern that other parts of the system can copy. Over time, secure coding foundations become more strategic when they are treated as part of how software is written everywhere, not just in a few critical features. That might mean creating a small library of approved helper functions for database access, web requests, and data parsing, and updating coding guidelines so they include specific examples of safe patterns. Code review checklists can highlight a limited set of high-value bug classes, so reviewers build a consistent eye for them. At that point, new projects start secure by default, and review cycles focus on design and threat modeling rather than basic mistakes.
Change is another area where secure coding shows its value. When the team adds a new third-party integration or exposes a new endpoint, a strong foundation leads people to ask the same set of questions every time. What data crosses this boundary? How is it validated? What happens when it fails? How is that captured in logs? Instead of inventing new solutions from scratch, teams reuse known secure patterns, such as a standard way to handle user-submitted files or a common wrapper for external calls. That pattern mindset is what steadily reduces the bugs attackers count on, even as the system evolves.
The payoffs of secure coding foundations show up in very practical ways. When fewer basic bugs make it into production, there are fewer emergency patches, fewer late-night pushes, and fewer surprise findings from assessments. Security teams can spend more time on architecture and design risks instead of filing the same injection or cross-site scripting tickets over and over. Developers spend less time on fire drills and more time on purposeful improvements. Releases feel more predictable because security issues appear earlier and in smaller, easier-to-fix forms. There are honest trade-offs as well. Building secure coding habits often means slowing down a little at first, especially when refactoring old code or creating new helper libraries. Reviewers need to learn how to spot certain bug patterns and feel comfortable calling them out. Teams may need to adjust their culture so that pointing out security concerns in a review is seen as collaboration, not criticism. There is also an ongoing cost to keeping patterns and libraries up to date, especially as frameworks and languages evolve. Secure coding foundations also has clear limits. It does not remove the need for strong identity and access controls, good logging and monitoring, careful configuration, or timely patching. A codebase can be written with secure patterns and still be at risk if it sits behind weak authentication or relies on unpatched components. Secure coding also cannot fully prevent logic flaws, where the system behaves exactly as designed, but the design itself is unsafe or unfair. The right way to view it is as a major layer in a defense-in-depth approach, not as a replacement for other controls. You can recognize failure modes in secure coding by listening to how teams talk and watching how they work. One common pattern is heavy emphasis on one-time training sessions with little follow-through in code review or library design. Another is a culture that measures success only by tool output, as if reducing the number of scanner findings were the goal. In that environment, people focus on clearing individual tickets instead of fixing the root patterns, and the same types of bugs reappear. Developers begin to see security checks as random obstacles rather than an integral part of quality. Shallow adoption also shows up in vague guidance. Telling people to avoid injection or be careful with user input does not help when they are under deadline and staring at a blank editor window. Without concrete examples, standard helpers, or realistic checklists, the pressure to ship wins every time. You can hear this when reviewers say they trust the framework without understanding which parts it actually covers, or when incident reviews end with the conclusion that someone simply needed more training. Those situations usually reflect missing foundations rather than individual failure. Healthy, secure coding cultures look different, and you can hear that difference in everyday conversations. Code review templates highlight a few specific checks, such as whether all data access uses approved helpers or whether all external input is validated before use. Shared libraries make the safe way the easiest way, so choosing the secure pattern does not feel like extra work. Automated tests exercise odd and malicious inputs on purpose. Over time, scanner reports show fewer repeats of the same issues, and when new findings appear, teams can fix them more quickly because the patterns are familiar. In retrospectives and design discussions, security concerns begin to sit alongside performance and maintainability as normal topics, not special events. Developers mention how a new feature will validate input or handle errors as naturally as they talk about caching or response time. Metrics may show fewer incidents tied to basic coding mistakes or shorter time to fix those that do occur. None of this feels dramatic, but it is the quiet progress that steadily removes the bugs attackers depend on.
At its heart, Secure Coding Foundations is about turning security into a normal part of writing and changing code, rather than a separate stage at the end. It lives in the small decisions about how input is handled, how data is accessed, and how errors are exposed. When those decisions follow simple, shared patterns, the most common vulnerability classes become rare, and teams spend less time fighting preventable fires. That shift changes how both development and security feel day to day.
As you think about your own environment, focus on where these foundations already show up and where they are missing. Look at the busiest features, the most exposed endpoints, and the parts of the system that handle sensitive data. If you see clear patterns, shared helpers, and consistent reviews there, you are already shrinking the space attackers can use. If you do not, treat that gap as an opportunity. Small, steady improvements in secure coding can pay off in fewer incidents, calmer releases, and software that quietly resists the bugs attackers once relied on. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.